Chinese remainder theorem? Why we are discussing Chinese remainder theorem? In session number 1, we discussed what do you mean by dividend, divisor, quotient and remainder. Remainder 1, numerator is divided by denominator. In session number 3, I gave a flow chart. I will repeat this flow chart. Then you will come to know what is the drawback. When the denominator is a composite number, when the denominator, it is a composite number. If the denominator, it is a composite number. If the denominator, if it is a composite number, first we will try to solve the problem using negative remainder. We will try to solve the problem using negative remainder. Not all the problems we will get the answer fast using negative remainder. Then we will use Euler's theorem. Then we will use Euler's theorem. Then we will use Euler's theorem. But even if Euler theorem fails, then we have to go to Chinese remainder theorem. Chinese remainder theorem. Chinese remainder theorem. Everybody knows what is Chinese remainder theorem. Only thing you do not know that it is a Chinese remainder theorem. Even from our 5th class, 6th class, 7th class textbook, we have discussed the application part of it, but we did not knew that the name of the theorem is Chinese remainder theorem. Now, why we are discussing Chinese remainder theorem? For example, if I take a question, let me see if I take this question. Suppose if it is there, this question is there. 3 power 101 divided by 77. Let me see what will happen if I use Euler's theorem. Let me see what will happen if I use Euler's theorem. Euler's theorem is used when the denominator, it is a composite number. 77 is 7 into 11. 7 into 11. So the quotient function of 77 is n into 1 minus 1 by p1. I will discuss in the next class why it is 1 minus 1 by p1. For everything there is a proof, sir. It is 1 minus 1 by 11. 1 minus 1 by 11. 77 cancel, it is 60. So if I apply Euler's quotient function, this is nothing but 3 power 60 divided by 77, it is 1. So if it is 60, even for the multiples of 60, 3 power 120 divided by 77, it is 1. 3 power 120 divided by 77. Which value we require? 3 power 101 we require. 3 power 9 into 3 power 1 divided by 77 is 1. Now if you observe here, this is what we require it. Doing this one, 3 power 9 divided by 77. Try to find out whether the remainder is plus 1 or minus 1. 3 square is 9. 3 cube is 27. 3 power 4 is 81. So writing it as 3 power 4 whole square, isn't it very complicated? 3 power 4 whole square into 3 power 1 into x divided by 77 equivalent to 1. All these steps, it will take a little more time than the usual time. In the previous problems, it is a very simple equation. Just by looking at the equation, we got the answer. But for some numbers, it is, if the quotient function of the denominator, it is 60. What is the multiple of 60? 120. What is it given in the question? 101. Is 101 close to the quotient function of denominator? Are its multiples? Definitely no. Again, I am repeating. Quotient function of 77 is 60. 60, 2 times it is 120. 2 times it is, in fact, it is 19. It is 19. It is not even 3 power 19 divided by 117. 3 power 4 into 3 power 3. A lot of calculation it is taking. I hope it is clear. So this is the drawback of, please make a note, there is a calculation mistake. It is 3 power 19. First make a note, sir. First make a note. First make a note. We will see what is the drawback. Unless we write down the drawback of Euler's theorem, we will not be able to appreciate Chinese remainder theorem. Euler's theorem Euler's theorem. If the question is of the form a power x divided by n equivalent to 1, a power x divided by n equivalent to 1, if x is closer to totient function of n, if x is closer to totient function of n, are its multiples, totient function of n are its multiples of totient function of n, then Euler theorem is used effectively. Euler's theorem is the best method. Euler's theorem, it is the best method if the power of the numerator is closer to phi of n or multiples of phi of n. Please make a note of it, sir. If the power of the numerator is not closer to the totient function of denominator, it might take a little more time. Finding out which power of numerator by denominator gives you plus 1 or minus 1. That is the complexity in negative remainder. If the power of the numerator is not closer to the totient function of denominator or its multiples, then Euler's method is ineffective. The power of Euler's theorem only lies if the power of numerator, it is closer to totient function of denominator or multiples of totient function of denominator. Please make a note, sir. Please make a note. I am doing the arrow above. If the denominator, it is a composite number. Just look at the question. If the denominator, it is a composite number. Step number 1, apply negative remainder. Step number 2, negative remainder is not helping me to solve fast. Then use step number 2, Euler's theorem. If the power of numerator is not nearer to the totient function of denominator or its multiples, then use Chinese remainder theorem. Now, we will see in detail what is Chinese remainder theorem. Very, very important theorem. Chinese remainder theorem. The first thing is, Chinese remainder theorem is used when the denominator is a composite number. If the denominator is a composite number, then Chinese remainder theorem is used. Chinese remainder theorem is used when the denominator, it is a composite number. Write down the composite number. Write the composite number as a product of co-prime numbers. If the denominator, if it is a composite number, Chinese remainder theorem states, write the number as a product of co-prime numbers. If you can write composite number as a product of co-prime numbers, then this method is the efficient method. Now, square of a prime number. You take a prime number and square it. Square of a prime number cannot be expressed as a product of co-primes. Square of a prime number cannot be expressed as a product of co-primes. That is the demerit of Chinese remainder theorem. Chinese remainder theorem, the first thing is where the Chinese remainder theorem will be used. Chinese remainder theorem helps us in eliminating incorrect answer options. It is a beautiful method where you can eliminate incorrect answer options. Helps us in eliminating incorrect answer options. Please make a note of it. Chinese remainder theorem. Chinese remainder theorem is used, step number 1, when the denominator it is a composite number. The utility of Chinese remainder theorem is only when the denominator it is a composite number. Write the composite number as a product of coprimes. As a product of coprimes. Now the question arises, can every number, composite number, can it be written as product of coprimes? No. A square of a prime number cannot be written as a power of prime number, coprime numbers. 9. In how many ways can you write 9? 1 into 9, 3 into 3. 3 and 3, HCF it is 3. What do you mean by coprime numbers? Coprime numbers, HCF is always 1. HCF is always 1. HCF is always 1. Square of a prime number, 3 square, 5 square, 7 square, 11 square. P square, P into P. HCF of P comma P, it is P. So therefore, Chinese remainder theorem, probably it will not be best method to solve the problems if when the denominator it is a composite number and the composite number is a square of a prime number and it is a square of an prime number. Extremely important point. Any student who is preparing for any exam other than CAT, next 15 minutes, pay attention, you will solve a lot of problems. Even though you are not good in Euler theorem and a negative remainder, you can eliminate few incorrect answer options just by looking at the question. That is the power of Chinese remainder theorem. Chinese remainder theorem in reminders is like a digital sum. In mathematical operations, digital sum will never give you incorrect answer options, will never give you the right answer option, will eliminate incorrect answer options. Chinese remainder theorem also it is like this. We have seen the drawback of Euler theorem. Again I am repeating, drawback of Euler theorem is if the power of the numerator is nearer to the quotient function of denominator or its multiples, then Euler's method is the best method. So this is the introduction to Chinese remainder theorem. Very, very important key point is if the denominator it is a composite number, write the number as a product of coprimes. Write the number as a product of coprimes. Please underline this one. It helps us in eliminating incorrect answer options. It helps us in eliminating incorrect answer options. Karthik, most likely today night you should get an update. If not today, worst case tomorrow morning, you will get an update about the CAT 2021 batch at probably the lowest price in the market. I myself will come and give an announcement and I will take selected serious and sincere students. All the classes are taken by me. All the classes are taken by me. Helps us in eliminating incorrect answer options. Now, what do you mean by composite number written? 12 is a composite number. It is, the theorem is telling that don't write it as a product of non-coprime numbers. 2 into 6. 2 and 6 both are even numbers. So even numbers can never be coprime to each other. So it is nothing but 3 into 4. It is nothing but 3 into 4. If the denominator it is 12, do it by 3 and then do it by 4. Do it by 3 and do it by 4. Suppose if it is 36, please don't do it with 2 into 18 because it is not product of two coprime numbers. Don't do it with 3 into 12 because 3 and 12 HCF it is 3. Do it with 4 into 9. Do it with 4 into 9. I hope you got an idea how you should split the number as a product of factors. How you should split the number as a product of factors. If you want to know this is what we did it. What we did in our 4th class textbook. What is the divisibility rule of 6? It is the divisibility rule of 2 and 3. So we used Chinese remainder theorem, but we do not know that the name of the theorem is Chinese remainder. 10 is nothing but 2 into 5. 10 is nothing but 2 into 5. I hope the idea it is clear. Idea it is clear. Suppose see here. If you see the 8 in how many ways can you write 8 as a power of a product of two coprimes 1 into 8 and the next one is 2 into 4. Even that is also not possible. Even that is also not possible. Even if you take 625, 625 is 5 power 4. 1 into 625, 5 into 125, 25 into 25, 25 into 25. These 5 into 125, both are not coprime. Both are not coprime. So 4 is there. 4 is 1 into 4 and 2 into 2. You cannot write it as a product of coprimes. That is the reason. Divisibility rule of 2. 4, 8, 16, 2 power n is different. Divisibility rule for 3 square, 3 cube, they are also different. Divisibility rule for 5, 5 square, 5 cube, so on and so forth are different. So for a composite number, square of a prime number, I just started with the square of a prime number. Can I take cube of a prime number? 2 cube is 8. 1 into 8, 2 into 4. Both cannot be written as a product of coprimes. You can start with the square, cube of a prime number, fourth power of a prime number, all this one. They cannot be written as a product of coprimes. Simplest is the square of a prime number. Any higher powers also, it cannot be written. For example, 7 power 4 is there, which is 49 into 49, which is 1 into 2 or 0, 1, 7 into 343. These are the factors. These are the factors. So total 5 cases we got. 1, 7, 49, 343, 2401. None of them HCF, it is 1. I hope this idea it is clear. Listen carefully, sir. At least as many questions as possible, I will solve it. Suppose question is remainder 1. Remainder 1. I am not going to solve. 53 power 11111 divided by 51, it is there. 51, it is there. Options are like this. 24, 25, 26, 27. 24, 25, 26, 27. I made a statement. Chinese remainder theorem can help us in eliminating incorrect answer options. Can help us in eliminating incorrect answer options. How it helps us in eliminating incorrect answer options, we will see. This is the point which I said. So let us see how it is used. We are not, first I will tell you the basic problems, then I will get into the level 2 problems. Finally, I will take advanced level problems. 53 power 11111 divided by 51. Step number 1. 51, it is a composite number. So you can write it as a product of coprimes. Product of coprimes, it is nothing but 3 into 17. 3 into 17. Step number 2. We have to use the divisibility rule of 3 and the divisibility rule of 17. Let me use the divisibility rule of 3. Divisibility rule of 3. Let me use the divisibility rule of 3. 53 power 11111 divided by 3. 3 18s are 54. Minus 1. Minus 1 power odd is minus 1. What is the positive remainder? Positive remainder, it is nothing but 2. 3 18s are 54. Minus 1 power odd is minus 1. Positive remainder, it is nothing but 2. So 53 power 1111 and it is of the form 3k plus 2. Answer when divided by 3. Answer when divided by 3. First I will do. Answer when divided by 3. It should be of the form 3k plus 2. Answer when divided by 3. It gives a remainder 2. This when divided by 3. It should give a remainder 2. 24, 3 into 8. 25, 3 into 8 plus 1. 27, 3 into 9. So the only possibility it is, the only possibility is 26. Answer for this question is 26. Hey Anil sir, what if the answer is 32? Then what we will do is, which I will explain it in the next slide. Then I will do it with the other number, which is 17. Then I will find out the remainder of this number. It should be divisible by 3 and 17. It should be divisible by 3 and 17. When divided by 3, it gives a remainder 2. When divided by 3, it gives a remainder 2. Answer when divided by 3, it should give a remainder 2. It should give a reminder 2. Anything which is not of the form 3k plus 2, it will not satisfy. Again, put a star mark on this. I will come back to you and I will prove you that why the answer when divided by 3, it should give a reminder 2. Answer when divided by 3, it should give a reminder 2. I hope the idea it is clear. First question, how we eliminated answer options? First I wrote the number as a product of co-prime numbers. 3 into 17. So 53 power 1111 divided by 3, it is plus 2. So when divided by 3, remainder 2. If there is no option other than 26, all the 3 can be eliminated. If there is one more option, then I will divide by 17. I will do it in a traditional method. My entire scope is how to tell you to eliminate incorrect answer options. I hope this concept is clear. Second one. For example, reminder. For example, if the question is 3 power 40 divided by, or we will take the exact questions only. Suppose 13 power 400 divided by 187, eliminating the answer options. First I will write here, then I will do it, then it will be clear, so that both the concepts will be clear. Eliminating incorrect answer options. Just by looking at a question, what you do is 13 power 400 divided by 187. I will do method number 2 here so that it will be clear. 187, it is a composite number, so it is 11 into 17. 187, it is a composite number, so it is 11 into 17. So first do it with 11. 13 power 400 divided by 11. Then do it with 17. 13 power 400 divided by 11. 13 power 400 divided by 17. So these are nothing but 11 is a prime number. So 13 power 10 power 40 divided by 11. These 1. So answer when divided by 11, it should give a remainder 1. If it is 17, power will be 16, 16 2s are, 16 5s are, divided by 11. 13 power 16 divided by 17, remainder is 1. That means the answer for this question is, when you divide this by 187 is 11 into 17. When divided by 11, I should get 1. When divided by 11, I should get 1. When divided by 17, I should get 1. When divided by 11, I should get answer 1. When divided by 17, I should get 1. Eliminate the answer options. Why it is behaving like that? Let me prove it. 13 power 400, when divided by 11, the remainder is nothing but 1. 13 power 400, when divided by 17, remainder is nothing but 1. Both are representing the same number, 13 power 400. So you can equate it. 11a plus 1 equivalent to 11a plus 1 equivalent to 11b plus 1. 1 cancel. Both of them it will be equal at lowest value 0. Both of them it will be equal at lowest value 0. So 11 into 0 plus 1. That means 1 is the lowest remainder possible. This number is divisible by both 11 and 17. So divided by 187. These perfectly cancel. 13 power 400. 13 power 400. When I divide by 11, I got a remainder 1. When divided by 17, I got a remainder 1. So both of them are representing 13 power 400. 11a plus 1 equivalent to 11b plus 1. 1 cancel. The lowest value is for a0, b0. So 11 into 0 plus 1. Both of them is giving you the same positive remainder. What is the form of the number when it is divided by two different numbers and gives the same positive remainder? 1 plus LCM of 11 and 17. So this is nothing but, this is the form of 13 power 400. Answer is nothing but 1. Answer is nothing but 1. When divided by 11, it gives a remainder 1. When divided by 17, it gives a remainder 1. When divided by 17, it gives a remainder 1. Suppose if the question answer options are like this: 23, 35, and 45, and none of these. If the answer options are like this: 23, 35, 45, and none of these. 13 power 400, when divided by 11, remainder should be 1. Answer when divided by 11, remainder should be 1. Answer when divided by 11, answer remainder should be 1. Answer when divided by 11, remainder should be 1. This cannot be the answer. Oh, when divided by 11, I got a remainder 1. Only 1 I eliminated. Answer when divided by 17, I should get a remainder 1. Answer when divided by 17, I should get remainder 1. 17 into 1 plus 6. 17 into 2 plus 11. Answer for this question is 9. You probably no need to equate both of them. If the answer options are not there, if the answer options are not there, you have to equate both the equations. Within 10 to 15 minutes, once I start solving problems, then you will eliminate how you should start solving this problem. When divided by 11, remainder 1. When divided by 17, remainder 1. When divided by 11, remainder 1. 35 it is out, which is 11 into 33 plus 2, 11k plus 2. When divided by 17, it should be 1. 23 and 45. Suppose if there is more than one answer option, which is possible, that number probably will be a number greater than 187. Further divide, you will get the answer. There is no possibility where you will get two reminders. Because I am finding the case where the positive reminders are same and the number is divided by multiple numbers. There are no two cases possible where you will get this answer. Now see here. 13 power 400, 11a plus 1, 11b plus 1. Suppose this question let us solve. 3 power 101 divided by 77. 3 power 101. 5 to 10 minutes. Please keep listening to each and every step how I am solving the problem. Then it will be easy for you. 3 power 101 divided by 77. 77, it is a composite number. So it is 7 into 11. 77, it is a composite number. So it is 7 into 11. These are nothing but, first I will divide by 7. 3 power 101 divided by 7. Then I will divide it by 11. Then I will divide it by 11. I will do both. One it is divided by 7, another divided by 11. Now if you see here, 11 is the prime number. So a power p minus 1 power p into 3 power 1 divided by 11. I hope you are all there with me. A power p minus 1 divided by p. 3 power 10 divided by 11. 3 power 10 divided by 11. It is nothing but 1. 1 into 3, 3. 1 into 3, 3. So answer option. When you divide by 11, how much remainder it should give? 11b plus 3. Again I am repeating. 77, it is a composite number. Composite number is 7 into 11. 3 power 101 divided by 7. So we will also do it for 7. Remainder 1. 7 means again a prime number. 3 power 6. 6 16s are 96 into 3 power 5 divided by 7. This is again 1. 3 power 5 is 243. 243 divided by 7. 7 3s are 21. 33. 7 4s are 28. What is the remainder? 5. Answer option. When divided by 11, it gives a remainder 3. When divided by 7, it gives a remainder 5. Go with the answer option. Before you equate both the equations, go with the answer option. 3 power 101 divided by 7. 3 power 6 power 16 into 3 power 5. 3 power 101 divided by 11. 3 power 10 by 11, it is 1. 1 into 3, 3. Answer when divided by 11, remainder 3. Answer when divided by 7, remainder 5. When divided by 11, remainder 3. When divided by 7, remainder 5. Play with the answer options. Let us first equate it, then we will check. 7a plus 5 equivalent to 11b plus 3. So 7a equivalent to 11b plus 3 minus 5 minus 2. So 7a equivalent to 7b plus 4b minus 2. 4b minus 2. Divisible by 7. Divisible by 7. 4b minus 2. It should be divisible by 7. 7a divisible by 7, 7b divisible by 7, 4b minus 2, it should be divisible by 7, 4b it is an even number, 2 it is an even number, so equate it with, not with 7, 7 is not possible, equate with the next multiple, so 4b equivalent to 16, b is nothing but 4, b is nothing but 4, if b is nothing but 4, see here, 7a equivalent to 44 minus 2, 42. A is nothing but 6. A is nothing but 6. Substitute any value, you will get the answer. 42 plus 5, 47. 44 plus 3, 47. In both the cases, you got the answer 47. I hope the step-by-step approach of how to solve the problem, it is clear to you. Suppose if the question is, if the answer options are like this, answer options are like this, 39, 33, 47 and 77. 39, 33, 47 and 77. If the answer options are like this, answer when divided by 11, it should give remainder 3. It is perfectly divisible by 11, out. 39, 11 into 3 plus 3, out. 11 into 7, out. The only answer is 47. Only answer is 47. You came to know the traditional way of solving the question. And once you got till here, please keep an eye on the answer option and try to eliminate the approach. 77 is 7 into 11. 77 is 7 into 11. First I divided by 7. I got the answer 5. Then I divided by 11, I got the answer 3. 3 power 101 when divided by 11, remainder 3. 3 power 101 when divided by 7, remainder it is 5. So, sir, how are you eliminating, directly writing the answer? B is 4. 11b plus 11 into 4 plus 3, 47. It is also 47. So, 3 power 101 is nothing but, both the cases, the remainder it is same and it is a number divisible by 7 and 11. So 3 power 101 is 47 plus LCM of 7 and 11 divided by 77. So this will get cancelled. Answer is 47. Extremely important model. Once you know the model, you can solve a lot of negative remainder and an Euler's theorem problems by using this. I hope the idea it is clear. 3 power 101 divided by 77. 77 it is a composite number. Chinese remainder theorem states, write the number as a product of coprimes. Write the number as a product of coprimes. Even To the Euler's theorem problems also, you can solve it. Suppose, see here. See this question. These are Euler's theorem problems. Now see here. Suppose if the question is 8 power, suppose if it is 5 power 37 divided by 63. 63, it is a composite number. So it can be written as 7 into 9. 7 into 9. First do it with 7 or do it with 9. 5 power 37 when divided by 9. Divided by 9. 9th quotient function is 6. So 5 power 6 power 6 into 5 power 1 by 9. Into 5 power 1 by 9. This one. Answer is 5. Answer when divided by 9, it should give a remainder 5. Answer when divided by 9, it should give remainder 5. I hope the idea it is clear. Similarly, you do it with 7 also if there are more than one answer options. 5 power 37 divided by 7. So these are nothing but 5 power 3 power 12 into 5 power 1 divided by 7. 125, 7. 1s are 7, 7. 8s are 56. Minus 1, it is 5. So when divided by 7, it gives a remainder 5. If I equate both of them, A0, B0. So the answer is 5. That is what we got the answer. That's what we got the answer. I hope the idea it is clear. Euler's theorem is used when the denominator it is a composite number. When the denominator it is a composite number, I will use Euler's theorem. 143. 143 it is nothing but 9 into 17. 150, sorry, not 143, 153. It is 9 into 17. So these are nothing but 2 power 100 divided by 9. 2 power 100 divided by 9, which is nothing but 2 cube power 33 into 2 power 1 divided by 9. 2 cube power 33 into 2 power 1 divided by 9. 8 by 9 is minus 1. Minus 1 into 2 minus 2. Positive remainder is 7. Answer when divided by 9, it should give remainder 7. Answer when divided by 9, it should give remainder 7. I hope the idea it is clear. 153 is 17 into 9. 2 power 100. 2 power 100, it is minus 2. So it is plus 7. If there are more than one answer options, 2 power 100 divided by 17, which is 2 power 4 power 25 by 17 minus 1. So it is 16. 17b plus 16. Answer when divided by 9, it should give remainder 7. Answer when divided by 17, it should give remainder 16. Just by looking at the answer option, so we can say that 16 is the possible case. That is possible when A is 0 and B is 0. When A is 0 and B is 0. I hope this question is clear. This question is also clear. Sir, what if it is the square of a prime number or a cube of a prime number? You can eliminate a lot of incorrect answer options. If the denominator is a square of a prime number or a cube of a prime number, then you can probably eliminate answer options.